Really gone through this XML. What does an XML mean is like it's an extensible markup language. So it doesn't have any predefined tags like HTML. So we can have our custom tags. Like markup language is something we represent, something we use to represent our data, right? So it is basically derived from the HTML. So HTML is a kind of a standard rules which are being followed by HTML as well as HTML is the standard generalized markup language. It defines some set of standards or rules. Okay, it is not a markup language, but it actually defines the rules as we have discussed earlier. So, due to some deficiencies in HTML and HTML, we have introduced this XML. But when we compare both HTML and XML, both are different. Mainly, the HTML is useful for our layout. So, whatever we are able to see in our web browser, whereas XML is like a kind of a transport, like it's a markup language which helps to carry the data from the server to push from your server to your client. Dynamic data is nothing but some, for example, if you consider any person, if the person has some details like his name, ID, date of birth, and all. So if all the details are dynamic, then we can pass those particular data using this XML. So mainly it is useful for transport of data, useful for the data exchange. Okay. And the rules for the XML are strict, like you have to appropriately close the tags and all, not like a HTML. So HTML has some lax syntactic rules. It doesn't follow some, even if you do not close appropriately or if you do not use the nestings properly, like wherever you have two parent, like you have two elements like parent and child element. If you don't nest them properly also, HTML works, but in case of XML, it doesn't. And HTML has its own complexities due to which we are actually opting for the XML. So it defines some standards, HTML, and we cannot directly use HTML because it is very complex for any transport of data kind of things. Okay. So to just summarize, two problems with HTML is like HTML is used to describe the general form and layout of the information without constraining its meaning, and some fixed set of tags and attributes are there in HTML. So given tags must fit every kind of document, like nowhere to find particular information. We cannot customize the things, and there are no restrictions on the arrangement or the order of the tag appearance in the document. Okay. So using this HTML, we can have the own tags and attributes written. But the problem with HTML is like it is generally used to define a new markup language to meet those needs. And also it is very complex and it's difficult to use, like very difficult to build a parser for it. Like for example, you have a JavaScript parser, right? So similarly, whatever the custom tags you're going to write in HTML, you should have, it is very difficult to build a parser for it. Okay. And there are certain problems with HTML also. You can refer through the different problems of HTML and HTML as per your textbook. So we can simply say like XML is not a replacement for HTML. Okay, it has its own goals. Like as HTML is for markup language, XML is a markup language which is like defining for the exchange of data and all. Okay. The XML tags are also like self-descriptive tags. They are actually easily understandable by everyone. So here you can see the syntax of the XML, the different levels of syntax. When do we call and some documents are well formed? So well formed documents conform to the basic XML rules. So when we call a document to be a well formed XML documents, like if the below criteria is met, then we can form the then we can say like XML documents are well formed. So as we discussed, like all the begin tags have matching ending tag. So whenever you open a tag, you have to appropriately close it. Like for example, if you have some name tag, okay, you have to appropriately close it. And if a begin tag is inside an element, the matching end tag is also. Like for example, inside the name you have some middle name. So this middle name should also be present inside the name tag. So whatever all the elements should be placed inside the name tag, but it should not be like this after the name. Okay, it should not be like improper nesting is not allowed in the XML. So if there is one root tag that contains all the other tags in a document. So as in HTML, here also you will have one root tag like kind of HTML. It should have only one root tag, and attributes must have the values assigned. The value must be quoted. For example, if name has some attribute called something XYZ, then it should be properly quoted like this. Okay, if you have the attribute like image src, you have your name some attribute, then whatever the value you are giving for this attribute should be properly quoted. And the char set and this less than and greater than, right, whatever we are using here, and can also appear with a special meaning. So apart from these things, whatever the character set you are using in your XML, which we'll see uh, in the further sessions, should also be have the appropriate structures. Okay, so if it follows all these rules, then we call it as an well formed documents. Okay, and valid documents are well formed and also conform to a schema which defines details of the allowed content. So now that we have understood about the well formed XML documents, we need to understand about what is schema. So this we will understand going forward. Okay, it's just like validity is tested against a schema. Schema is nothing but a set of rules against which we are validating the particular XML document. Okay. So XML document structure. So XML document uses two auxiliary files. Okay. So one is it specifies a tag set and syntactic structural rules. Okay. It will define like what are the structural rules that we have to follow, and also how do we represent a tag set like name, we have seen, right, those things. And it also contains the style sheets to describe how the content of the document to be printed. So as we have the CSS style sheets, for XML also we can have a dedicated style sheets to display the content. Okay. So styles like cascading style sheets and XSLT is the extensible style sheet for the XML. So here XML documents are made up by the following building blocks. So these are the building blocks by which the XML is actually made up of. We have elements, tags, attributes, entities, PC data and C data. So let us go through the each building block in detail. So when we discuss about the elements, elements are the main building blocks of both XML as well as HTML documents. So elements can contain some text, other elements, or it can be empty as well. So elements we have seen, right? Some kind of a starting tag should be like this, okay? And the element tag should be like this. That can be custom, either a person or based on the requirement, your name or some add information or anything. So attributes, this is very similar to HTML attributes. It provides extra information about the elements. For example, image src, we have given some source, right? So this is nothing but your attribute. And PC data means parsed character data. So we have two kinds of data here, parsed character data and character data. Parsed character data is nothing but which the text that can be parsed. For example, JavaScript parser parses the data, right? So in the similar way, when we have the PC data displayed in our XML that we are going to see forward in the example, how do we write a PC data? So this is mainly useful for parsing whatever the text that is found between the starting tag and the ending tag of the XML documents, that will be able to that particular browser can be able to parse the data. Okay. And C data is the exactly opposite to that. It also means a character data, but it cannot be parsed by a parser. So tags inside the text will not be treated as markup and entities will not be expanded. So whatever the tags that are, like for example, you can see here at NBSP. So this is a C data. Like this cannot be parsed, but what is this means, we have seen in our HTML, right? It inserts space in our HTML. So these are the examples of the C data and BSP. Okay. So past data, PC data means, for example, in your P tag, you have written some data. Hi, hello. So it can be detected by the browser and it can be parsed with the respective XML parsers. Okay. PC data. But whatever the data you write for the C data, okay, you write this NBSP. So this will not be parsed by the, sorry, something wrong. Yeah. So if you write like this, NBSP or something like LD, we have seen, right, different types of entities. We call them as entities actually. So if you write these things, it cannot be like this is the example for the C data. Okay. These cannot be parsed by the browser. HTML entity reference NBSP. Okay. Now coming to the entities. So an XML document has a single root element but often consists of one or more entities. For example, as we have the HTML as a root or a parent or a root element, here XML will also have a root element, but it can have multiple entities. Like we have seen, right? NBSP, less than, greater than. Okay, these are multiple entities, and XML document has a single root. Okay, the statement got repeated here. So consists of one or more entities that are logically related collection of information. So if you have multiple entities in a page, each will have its like across the entities you can have a relationship. Okay, and entities range from a single special character to a book chapter. It means like the entity can range from a small character like lel lt, or it can be multiple lines of text. Okay, it can be a large amount of information. So I hope you are clear about the element. Okay, what are the different building blocks we can see here for XML documents? In order to start your XML document, you need to understand each and every building block. Okay, and element is nothing but the tags you have seen, different types of like starting and closing tags and all elements tags. And attributes, we can see like which gives a special information like image src, and entities are lt, gt and bsp are all different types of entities. pc data means passed character data which can be passed or detected by a browser within the tags. And c data, it cannot be passed, but in the case of like if you give some nbsp or something, it will give a space in your respective pages. Entity names, no length limitation is there. It must begin with some letter, dash or a colon, and can include some letters, digits, periods. So there are certain rules are there. You can go through the rules like how an entity name should be. Okay. So we will discuss about the document entities, entity syntax, and the character data going further. So let's move on to document type definition. So document type definitions, I think we have heard it before also. So it's nothing but when we, with respect to HTML, we have discussed like it's a kind of standard or rules which defines like what kind of HTML we are using, kind of things, right? So similarly here also DTT is a set of structural rules called declarations, and these rules specify a set of elements along with how and where they can appear in a document. So we can see like tags, attributes and entities here, and how do we specify the order and nesting of tags. Okay, specify which attributes can be used with which tags. Like with image tag we are using only src but not other attributes, right? For anchor we use href kind of. So with which tag which attribute has to be used will be. So these are the set of rules which are valid against this dtd. Okay, so this is the general syntax. Okay, how do we actually use it? Like we have seen, right, doc type html and all. So similarly we have this keyword. This is the general syntax. So this portion will not come under xml. It's like a kind of declarations. Okay, so while declaring the elements, see what is the basic difference between an element and a tag. So element is nothing but the tag with the content inside it. We call it as a complete element, whereas tag means it's a opening tag or either a closing tag or both. But element means all together text, opening and a closing tag. So here we have to define the declare the elements. So this is how we declare the element. Okay, so here we have seen the keyword, right? So we'll use the element name and content description. For example, element, I'll show you the example here, person, and we can have some age, some attributes related to that particular person. So content description specifies what tags may appear inside the named element and whether there may be any plain text in the content. Okay, element name and list of child names. This is the example, element memo. Okay, and any element you can take, it can be a person or anything. I'm writing a memo and these are the list of child elements I have, from, to, date. Okay, this is how the example it appears. So with the help of this DTDs, the application development will be simpler because we follow all the set of standards. So, and it is also not mandatory that all XML documents should have or need a DTD. Okay. And external style sheets are used to, like we have the external style sheets here as well. Like we have embedded the external CSS with the help of link REL in our HTML. Here we can also have a external style sheets in the XML. Like for example, if you have multiple documents, all the documents have the same kind of styling, then we can use the same external file embedded. So when are these DTDs actually used? So when the same tags and definition are used by the collection of documents. If you have collection of documents which should have the same set of rules, so in that case we generally use these DTDs. So to have some consistent and the uniform structure, we'll use the DTDs. And a document can be tested against a DTD to determine whether it conforms to the rules the DTD describes. And the application programs that processes the data in the collection of XML documents can be written to assume the particular document form. So these are some set of points which are mentioned for defining why the DTD is used and what is the exact purpose of using it. Okay. So without these DTDs, how complex the application will be to build and all. So like the CSS, we can have the internal embedded DTD, like an embedded in XML document, or we can have a separate file. So if we have any inappropriate DTDs, then it will become a challenge. So we have to make sure like either we use DTD or not. If used, it has to be appropriate. Element. This is the name, element name, and PC data. PC data means this is a kind of a rule I am applying. Okay, like it's a whatever the name I am giving, it's a parsable data that it can be parsed. Okay, Here we need to understand about the multiplicity also, alternate tags and sequence tags. So sequence of tags means whatever the tags we are going to specify, right? When we are declaring some parent like memo and form from child, or these are all the child elements, right? So we need to make sure like we properly nest the tags here. So I would also show you one example here. For this multiplicity, so how do you understand here? So child elements can have modifiers. For example, so you have seen the child elements like from, to, date and or all the things. So if you have plus, it means like one or more occurrences of the things. Star means zero or more occurrences. Question mark, zero or one occurrences. So these are the certain things you have to remember. So consider below the declaration, you can see this is the element declaration. Person, about person, parent, age, spouse and siblings are the children. So when I give a plus symbol, it means like it has one or more parents, person, and age, one age, spouse, possible, okay, zero or more occurrence. It's not mandatory, it can be there or cannot be there. So similarly, siblings star, zero or more occurrences. This is how we can understand the multiplicity. Okay. Types of the content of their parent nodes, okay, which are the elements. So these leaf nodes, whatever we are discussing, the data types of the content of their parent. Okay, parent has certain content like the children about age and all those things, right? So if we want to specify what kind of data it is, they'll use the leaf nodes like PC data, as we have discussed, right? So PC data is a parsable character data which can be parsed. Okay, like name is a parsed data and all. So let me show you an example here how the basic structure of a DTD will be. Okay, now we'll see the complete example of how a document type definition will be. File will be like this is a specification for set of multiple documents, whatever is using this particular element. For example, you have the XML version and encoding standards. So this plains.dtd, I will save it as plains.dcd. So I will run it and show you in a further class. So you just see the example here. You have a DTD keyword element. Okay, plains for sale is the root element. Okay, now here this is what actually we are talking about, planes for sale, and in the braces we have AD, like person, you have children, right? You have planes for sale and you have a children called AD, and plus multiplicity. So AD has more number of child elements. Okay, you are writing here under AD you have your different types of whatever child elements you have. For each element you are defining whether it is a parsable data or whether it is not a parsable non-parsable data like C data. Okay, so PC data, from here till state we can understand like this is a parsable character data. Okay, so whenever in multiple documents you want to use this color or model, so this is the rule or declaration. Okay, now we will discuss about the attribute list as well as entity. Okay, so this is the general syntax of the attribute list, element name, and the attribute name or attribute type, and the default value. So pluses means multiple occurrences. Okay, and what are the default values that the attribute has? Fixed value, required, and implied. So C is the entity. So instead of C, the value is CS now. So wherever you represent, sorry, I need to tell about attributes, right? Okay. Attribute, seller phone. So you have some seller email and all those things, right? So these are character data. So these cannot be parsed. Okay. Remember. And this is required. Like you have a mandatory. We have a required in DTD. So it is almost required. Email, it's implied like default, you can have a default things. Okay, if not specified it will take the default things. Some more additional information here. So fixed value which every element have and can't be changed. No default value is given, every instance must specify a value, so it is required to specify a value here. Implied, no default value is given here also, the value may or may not be specified, so it is not mandatory. Okay, so next we will go through the entities here. Okay, so how do you declare an entity? Entity name, entity value. So with percentile, a parameter entity; without percentile, a general entity. So these are the basic differences. How do you define a parameter entity and general entity? Let's see in detail here. This may only be referenced in the DTDs. Okay, generally when you are writing these declarations, right, these parameter entities can be observed in the declarations. Okay, whereas a general entity we can reference here. Okay, for example you have given JFK. Okay, this is how the declared entity behave. So this is John, so you can reuse it in other documents. Okay, and the entity name, entity remote form, like you are using an external CSS, here we can have a external entity. We have seen, right, entity can be from a single character to a large number of data, like a book chapter. So we have seen entity name, if it is has more information, like it's not just simple JFK, it's not about simple name. Okay, if it's more than a name, like it's a large file of data, in that case we can embed the external entity like entity name system. You have to use this keyword, this is has to be used, this is not defined by us. Okay, this is a kind of a keyword, and the file location, from which location you are trying to pick up this entity name. Okay, and the replacement for the entity is the content of the file. This replacement is nothing but the content of the file. So this is the example of the parameter entity. Okay, this is for your reference. So all together we will see like how a complete DTD will be there and a complete XML document will be there. And in XML document, how can you use internal DTD, external DTD? Okay. For sale, okay, .xml, you have a DTD here. Planes for sale, you have an XML called as planes for sale. Okay. For that you have a multiple child elements here. I'll open the planes.dtd as well here. Planes.xml. So here is your XML version encoding. So this is how you write your, see, planes for doc type, planes for sale is your XML file what you have written here. Okay. And system is your keyword and you are trying to embed the external DTD. Okay. This is how do you do the external DTD, planes.dtd. Where is your planes.dtd? It is here. Okay. For planes for sale is your XML. So inside your XML you have this AD which has multiple children, and you have the declarations. What is parsable? What are attributes? What are the different entities that goes on? Okay. So here is your XML. So it says like you used city, state, location, different tags which are defined in the DTD. Okay. Whatever defined here, that kind of a variable you are declaring, right? That you do in a DTD, you will have all the declarations. Okay, this is a var type, this is an int type, kind of things. And planes.xml, you use those tags. Okay. So how do you embed? Using this line, you will embed the external DTD. The same thing we have seen in our note is your XML. Okay. For which node.dtd is your external DTD. Just refer through this site. So this is your note.dtd, how it appears. So I have note, these are the child, and these are the different types of, you can say, is a data type. Okay. So just go through all these concepts. So this is your entity. Wherever you use NBSP in your XML page, it will be replaced by this value. Okay. Wherever you write copyright, it will display like copyright W3 schools. See, footer, I have written NBSP. Okay. At the this one, how actually when you write entity copyright here, while you write use it in your XML, you have to use this and symbol. Okay. Don't forget using that. So when you use writer, that is what an entity refers. Okay. When you use writer, when you use NBSP, these things are actually utilized here. Okay. Instead of writer, you will get this thing. Instead of copyright, you will get this thing. So let us see how it appears. So this is your XML output. Okay. It shows in a form of a tree structure. So what happened here? We got the writer Donald Duck, copyright W3 schools. Okay, these are the entities, and these entities why we use is like we can use it across multiple documents. Okay. So we have understood about DTD, how to write a DTD, parse it character data, entity, tag, element, building blocks of XML structure, and also we now understood how to define an XML. For each tag, we can define some set of rules in our DTD, and we can embed it using the external DTD like this, like system keyword we can use. Okay, system node.dtd. So these are mainly useful when you are actually doing some server and coding. Okay, it will not be represented. We can utilize the data, like we can iterate through different tags using for loop or for in loop like that, and we will get the name. Inside the name we will be able to, using looping we will get the data. So it's not basically for representation purpose. We just want to learn like how do we define it, and this is mostly used at the server end. Okay, so we have seen the external DTD, like we have some internal DTD as well. So a doc type declaration can either contain declaration directly or can refer to another file. So internal, this is the syntax. Okay. External, this is the syntax. Now we are, it's quite simple. You can refer through some examples. Namespaces. XML namespaces provide a simple method for qualifying element and attribute names used in the markup language documents by associating them with the namespaces identified by the URL references. So you can just go through this URL to get more information on namespaces. Why basically we use namespaces? So namespaces are like a means by which you can actually differentiate the elements and attributes of the different XML document types from each other when combining them together into other documents. This namespaces XML NS we have earlier discussed in our previous classes. So if you can recollect, you can remember, like when you are having some set of documents which are having the same names and attributes, okay, and we are trying to combine all together, then we'll have a name conflict, right, or an attribute conflict. In that cases, this namespace is very much useful. So XML allows user to create their tags. Naming collisions can occur, like when you have two documents have the same title tag. In case, how do you handle? Okay, using this XML namespaces, we can achieve those problems. We can overcome those things. We have to just use some colon prefix. Okay, this one. For the state, and XML namespaces colon cap. So whatever information I'm going to write for my states, okay, I should prepend this cap. So for my state, I'm writing name population, okay, and for my capital, okay, this thing, I have again name, capital population. For state, I have state name and state population, right? So I want to differentiate this name with the state name. In that case, I should use cap colon because I have declared in my namespace. This is under URL and this is under URL. I am combining two URLs information, state names and state population, as well as capital names and capital population. In that case, how this is an example how it appears. So basically, you can understand like namespaces are mostly useful when you try to combine more than one document which have the similar tags or attributes. Okay, that's simple. So let's move on to the next topic called XML schemas. Okay, fine. So this topic we are going to discuss in detail. Schema is a generic term for any description of an XML content model. So schema is again some set of standards or rules. So a schema is any type of a model document that defines the structure of something, such as a database structure, or you call it as a database schema, right? Some table schema. It's like kind of a layout, like with headings and all. So schema is something like here's like we have a schema is any type of a model document that defines the structure of something such as a database structure or any document. And here something is XML doc. Actually, DTDs are a type of schema. Okay, DTDs declarations, which are like very similar to the type of schema. And this XML schema is an XML document, so it can be parsed with an XML parser. So schema can be parsed with the help of a XML parser. And this term schema is used to refer, like it's again a W3C standard. Using W3C XML schema technology, you can get more information. And this XML schemas like DTD allow you to describe the structure of the XML document as you are using DTD for defining the structure, uh, to say whether it is well formed. So to check the, so schema also validates whether the document is valid or not. Okay, so syntax is different from XML. Like DTDs actually have several advantages, like its syntax is completely different from XML and it cannot be parsed with an XML parser. Okay, uh, DTDs cannot be parsed, whereas XML schemas can be parsed. Okay, and it is confusing to deal with two different syntactic forms. Actually, there are certain differences using which we can get through all these things. Certain advantages over the DTDs. Okay, it can be parsed as the first thing, and it also provides like more control over the different data types than a DTD does. So using this DTDs, we cannot specify, like strictly specify the data types. Okay, it cannot support the namespaces. Okay, it doesn't use any XML syntaxes. There are certain deficiencies in the DTDs. And the schema fundamentals, if we can see, documents that conform to schema rules are considered instances of that schema. So whatever documents that conform to the rules, so we can say that these are well formed documents. They are considered as the instances for the schema, like an object. You can the schema is also a kind of an object. Okay, unrelated idea of the classes, and it's an object in an O programming language. Also specify the data type of every element and attribute of its instance XML document. So earlier we haven't seen any data type specification in the DTD, right? So here we can see the data type, and also it specifies the structure of its instance XML documents. So it supports the namespaces. So XML schema language itself is a set of XML tags. So you'll have a, and the application being described is another set of tags. So we'll see this with the help of an example. So you can just refer to these points. Just like a DTD, it defines the structure of a XML document with correct syntax, it will be called as a code. But DTD is only like a well-formed thing. So these an XML based alternative to the DTD. So this is how the basic representation will be there. So it also specifies the name and data type. If you can see, string, 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 all these types, data types you can specify here. So this is a description of what we are talking about. You can just refer through these points, so it gives you more understanding of schemas. So XML document above consists of a root element called ship order that contains a required attribute called order ID. So we have understood about the attributes, right? So this is your root, okay, and it has some attribute called as order ID to differentiate if you have multiple ship orders, right? To differentiate from multiple ship orders, you can have the order ID for a unique thing, okay. And ship order contains of three child elements: order, person, ship to, and item. Three child elements are there, and each child element has its nested elements. So the item appears twice, and it contains a title and option note element, quantity and price. And the line above XML NS XSI tells the XML parser that this document should be validated against a schema. So this is basically a document, right? So this has to be validated against a schema. And the line XSI no namespace schema location shipper order.xst specifies where the schema resides. So for this XML, we have external DTDs, right? We have seen XML and external DTD. In the similar way, we have an XML, and this XML has to be validated against particular XST, okay, schema that has been given here. Against this XST, the existing XML has to be verified. This is the location. You have given some note system dot DTD, right? In the similar way, we have for XML, we have to use this notation. XML schema. Okay. So how do we actually create a schema is said here. We start by opening a new file that we'll call shiporder.xsd. We save it using .xsd. To create the schema, we should simply follow the structure in the XML document like this. When we want to create a .xsd, you have to start with this xs colon schema. This one, okay. So order person is a string here, data type. So this is the complete schema you have written. So each is a data type and complex types and all, okay. You have certain attributes you can go through. Max occurs unbounded means there is a meaning for this attribute. Maximum number of occurrences, okay, of an element, and minimum number of occurrences. So unbounded means we can have a multiple as many occurrences of the item as the author wishes, okay. See here, price decimal, quantity positive integer, okay. We can use the required also, like mandatory field we can use the name along with data type, we can use required field also. So this is how a complete XSD document, your schema. I'll just share this URL. This is a very good example of an XSD. Very much similar to DTD only, except the tags will differ. That's it. Like we have seen in the example, we have ship order ID, right? So ship order is the schema root tag, and XML NS attribute for the schema namespace, and so these are all we have discussed in our example. Okay. So the target namespace attribute declaring the namespace being defined, okay, and the element form default attribute with the value qualified to indicate that all elements defined in the target namespace must be the namespace qualified. So it has some certain attributes like XMLNS, target namespace, and element form default. You can go through these attributes and practice. Schema instances. So this is again the notation of a schema. So here we'll discuss about the schema instances in the XML. Continue the remaining topics in the next class, that is on second. Okay, not tomorrow, that is on second. Refer through this instance attributes. Okay, by the time we start the class you will be well aware of these things. So till slide 21 I am going to share the yesterday's and today's PPT as well. So till schema fundamentals and one example we are very clear. So from schema definition also we are clear. We need to discuss more on attributes. Data types, all we have just covered the string data types and all. Simple or complex data types we have seen in the example. So max length, that is called unbound, we have seen, right? So those some concepts has been covered in the example. Okay. So XML we have seen like it's mainly for exchanging of data. We have seen a well-formed XML, like how like it has to be properly nested, it has to properly closed and all. So we have discussed about the well-formed documents and also schema. Schema is like XML schema. Okay, it is very similar to DTD, but DTD has some deficiencies like it doesn't have a data type and the length is not restricted. Due to some deficiencies, we actually prefer the XSD. XSD is nothing but the XML schema definition language. Okay, XSD dot XSD like dot DTD. We have seen we have a dot XSD, which is a external schema definition language, like external schema we can specify in a file. And document structure we have seen. So this cascading styles and XSLT we are going to see in our further classes. So these two things we have already discussed. And we have seen how to build the XML by using these building blocks. And document type definitions, how do we start an element? Okay, element, parent and its child elements. Multiplicity, how can we use in more than one places, and also the parsed character data, required, implied, everything we have seen. So this is an example of a DTD. attributes we have seen, it can be from it can have a following default values, like if it's mandatory, required, fixed value and implied. Entities and all parameter entities, general entities. Parameter entities are like this example which we use in the DTDs, okay. Whereas this declared entity we can use here. So this entity can be a single word to a external file as well if it is a large file. How do you remotely access the external file? Entity name, system and the location. Namespaces, we have understood about the importance of the namespaces. When we combine different documents, XML documents, we need to make sure like there should not be any conflicts. XML schemas, we have seen the deficiencies of the DTDs we have seen, and fundamentals. Okay, structure of the instances, special purposes, why we are using these schemas. Okay, data types. So from this slide, we'll go in detail in our next class, schema, defining a schema and all. We'll see more examples. Just let me know if you have any doubts. Maybe I